Welcome back, this is Off by One, and today I'll be showing you my cheap, multi-floor, variable floor height elevator slash lift in Create 0.5. As you have seen before landing on this video, there are many elevator designs out there already. As far as I could see, most relied on a fixed height between floors. I found that those that don't were too expensive in either space or resources, certainly for my survival world anyway. Hence why I am here today. If you don't need a variable height between floors, there are probably cheaper ways you should do this, and you might want to look at other videos. However, if you want an elevator that can take you from the skies to your base, to your mine, all the way down to bedrock, this could be the one for you. On the topic of cost, I've tried to make this as simple as possible whilst still looking good. That being said, I recognise that some of the parts can be a bit of a pain to get, so I've tried to decouple the circuits as much as possible into required and optional, and I'll try and point out when something could be done more cheaply, albeit for a less cohesive experience. Right, enough word soup, time for a demo. On the right here we have the controls. There'll be one of these on every floor. We have the call button, that's the one I just pressed, to call the elevator to a current floor. We have an analog lever, which allows us to select our desired floor, as represented in this Nixie tube above. And we also have a confirm button, which locks in our choice and sends the elevator on its way. Now, technically, the call button functionality can be provided by the other two buttons that are here, or the lever and the button rather. Provided you know which floor you're currently on. So I'd recommend putting some signs up if you want to skip this part of the circuit. So as the jingle just indicated, our lift has arrived. So you can see our floor is currently set to 1, and this is floor 1, so if I press this button and get in, nothing happens, as we expect. We're on the floor, we wouldn't expect to move anywhere when we press that button. However, if I select floor 2, which is the one above, click the button and get in, the doors close and we begin to ascend. When we reach this floor, a little redstone connector behind us fires the circuit, the doors open, the jingle rings, and we're able to step out. This floor is, in terms of functionality, exactly the same as the one below. We are missing the light there, we're missing the signs, but all these buttons do the same things. So if I press the call button up here, because we're still at the top, it'll do nothing. However, if I press the confirm button with this lever set to floor 1 and get in, you can see the doors close and we head on down back to floor 1. So before I get into the tutorial, I want to quickly go over some of the pros and cons of this design so you can work out if this is the right one for your survival world. So first off, this is actually really cheap to make. As I said, compared to the ones that I've seen already. This circuit isn't all of it, of course. You have one of these per floor. But in terms of the actual controls, it's quite simple. The only other part that you need is this logic circuit here. Now this might look really confusing at the moment. Don't worry about that at all. I will cover all this in the tutorial. But in terms of actual redstone needed between this and the floor, that's basically all you need. So it's a much simpler system than some of these other ones that you might have seen already. So it's cheap. We only use 6 of the redstone links, I believe they're called. Yep, redstone links. So there's 6 redstone links required for the control circuit. So 4 in that circuit over there, and then 2 that power the clutch and the gear shift. Aside from that, the other components are pretty standard for what you would expect. You have the rope pulley, which is the sort of main part behind our elevator that allows it to work. You have the clutch, which turns off if you're at the correct floor, and you have the gear shift, which controls the direction that the elevator travels in. So if the target floor is above your current floor, it moves up. If the target floor is below your current floor, it moves down. And if you're on your current floor, then the clutch won't engage, so it won't matter which way it's facing. It's compact, as you can see. This entire circuit here fits into I believe it's, I think it's eight long. Yeah, it's eight long, 7 deep. And as I mentioned, you can have any height between each of the floors. And then another part that's quite nice is you can dynamically change floors. So if I want to add a intermediary floor in here, I could add that. I would just have to update the lever at the top here to say that this is actually now floor 3, for example, and the new one could be floor 2. And also, it doesn't rely on fixed rotation as some other designs do, which means that we can have basically any height between each of the floors. So in some designs, you need to have exactly 5 blocks between each floor, and you need to click buttons multiple times to move. On this one, it'll travel to exactly which floor you select, and as long as you've got the redstone connector at the other end, it'll be able to determine if you're at the right floor or not. So that's basically it for the demo. I'll see you again in just a moment to get started on the tutorial. So first things first, what blocks are you going to need? As I mentioned earlier, you'll need 4 redstone links for the control circuit, 2 for, or 1 for the clutch and 1 for the gear shift. You'll also need a number of blocks for basically the redstone operation circuit that stores the target value and current value, target floor and current floor rather, as well as a few comparators for that circuit. On each floor, you'll then need 1 redstone contact, a number of blocks of your choice, 4 redstone torches, 6 redstone repeaters, 4 redstone comparators, 2 redstone links. Now, one of these links is used by the floor selection button, so it fires off the target floor. The other one is used by the redstone contact to indicate basically to indicate the floor that you've just passed. We also have the analog lever. One of these is used by the selection interface. The other one is used with the redstone contact to indicate the current floor in that circuit that I just mentioned. We also have the buttons. Again, you could actually get off with one of these if you want to skip the call circuit, and you can probably skip one of these redstone comparators too in that circumstance. The doors, you could use pretty much any door that you wanted for this. I think that the framed glass door, and certainly the sliding animation of the framed glass door, is the sort of nicest way to have this. But if you want to use iron doors or anything else like that, works just the same. The redstone lamp, again, if you're low on glowstone, you might want to skip this part because all it does is light up in response to the confirmation button being pressed. And similarly, the note block is only used to indicate when the lift has arrived at your current floor. And the Nixie tube, technically if you have the engineer's goggles, then you can see the current analog strength on hover, so you might want to skip the Nixie tube in that scenario. However, I think that it does make it look quite a bit better. Of course, it is up to you. The lift itself, really simple. The only part that you actually need out of everything that's here is the redstone contact, and that's what's used to indicate the current floor as it passes. Each of these dies here is actually representing one of the channels that you'll have to create. So you'll need 4 channels with the redstone links in total for this. And then in my design, I use framed glass trapdoors to create the sort of pod around the lift. Other than that, you'll need 5 blocks for the floor. It would be 6 if not for the redstone contact. and then 6 for the backing wall as well. Certainly if you want it to be 3 high. If you want 2 high, you could do something different. Okay, so we'll start off with a quick clarification on my earlier point where I said it takes up a 8 by 7 space. Technically, only the call function of the control circuit on the main interface makes it a 8 by 7. Otherwise, you will only need a 7 by 7 space, with this bottom left corner being where our lobby is, our elevator being here, our control circuit being here, and our door control circuit being down here. In true YouTube/TV fashion, here's a hole I prepared earlier for this. You'll need to dig 3 down only in this top right corner circuit, and only if you want to build the fancy door controller that allows the doors to open smoothly at the correct floor. If you don't want to do that, you could build something simpler, however your doors might open on every floor even if you're not stopping there. So I'll just get started on the door controller. I'll grab a block. I'm going to use lime terracotta for this. You could use any block, cobblestone, basically as long as it conducts redstone, so no glass here, but any other standard building material should work. You're going to start off with a block in this top right corner, like so. You then want to place 2 blocks there like that, and your redstone contact should then go here, facing in the way. So when your lift comes down, its redstone contact will trigger this and it will start the door circuit. Then we'll place redstone here, here, and here, followed by 2 blocks, another block like so, another 2 blocks here, and 1 here like that as well. So it should look like this. Hopefully that was long enough to see the shape. You then want 2 repeaters here and here, a redstone comparator in subtract mode, a piece of redstone dust here, a piece here, and then you want a redstone torch like that. Now this is the basics of our door control circuit. This will ensure that when our elevator passes this floor, if it is just passing through, not waiting long enough to trigger the door circuit, the doors won't just open, close, open, close. So if I send a quick redstone pulse through this, you'll see that that piece of redstone at the end there didn't light up. However, if we're staying here longer than that, as in this is our intended floor, you'll see that redstone did in fact light up. So this circuit is just a sort of timed check to ensure that we're not just passing through. There is a little bit more to it, but I will cover that a little bit later. Okay, so the next part that we're going to need is our lobby. Now, if you listened to me earlier when I said that you will need to mine out the top right corner, this will essentially be your floor level that we're standing at right now. I'm going to grab a white terracotta for this. I'm going to place 1, 2, 3. I don't know how I managed to place one there. Like so. So that's a 4 by 3 area. We want to place 2 blocks here like this, and then your doors are going to be here and here, and you're going to have your pillars on either side or whatever you decide to place there. I'm going to put spruce logs in here, like so. Just get rid of those bottom ones because they're not technically needed. And actually the bottom one there will block the redstone signal if we're trying to use it later. So that is, it does need to be like that on this side. The other side, up to you, depending what types of doors you use. I'll then grab the framed glass doors from Create and place them like so. The nice thing about these doors specifically is that when you press one of them, both of them open. So if you press like that, they both slide in. Similarly, if you power one of them, they both open. So it means that you don't need a complicated double door redstone circuit to get these doors to open. You can get off with one torch on one side of them, so that's quite nice to have. The next part of this is our control board. I'm just going to use andesite for it. And actually, we need to expand our floor out a little bit, like so. So if you stop here, as in our 7x7 space, you've got all the floor space that you need for this without the call circuit. If you want the call circuit, all you need to do is place one block extra there, like so. I'll just pop in the bottom level. We have our analog lever there, like so, and our button here. I've used spruce because it goes nicely with these andesite bricks. Then want a torch on the back, so behind this button, followed by a redstone repeater. I've just set that to 1 tick. You could set it to 4 if you want, or anything really. It doesn't really matter. It's just used to block off this redstone comparator. Again, same as before in subtract mode, so that this 15 signal, it will override any value put into this if the button has not been pressed, like so. You'll then have your first redstone link here. I'm just going to set these to torches, redstone torches. This is going to be your floor target redstone link. Yeah, just remember that one for later. It doesn't really matter what you use in these frequency points as long as it's consistent. So you don't have to use redstone torches if you want to use something cheaper like cobblestone or andesite or diorite or other common resources that you find. Go ahead, it'll work just the same, but just make sure it's consistent. Okay, the next part of this has sort of two uses. This analog lever here is used by the floor detection circuit, but is also used by the call circuit. So you'll need this even if you don't have the call circuit. But it's also used directly by the call circuit. The call circuit is pretty straightforward here. All you need to do is pop a a comparator there, again in subtract mode, a piece of redstone dust here, and then you want to basically build a line above this torch here. I'm going to grab our, we don't have it, let's grab a lamp. Redstone lamp, that's that above. Again, the redstone lamp is optional. All it's used to do is basically indicate when that floor confirmation has been sent. I think it looks nice, but you don't technically need it. You could just place a regular block there if you are, say, low on glowstone. You'll have a redstone repeater above that. Again, doesn't matter what you set it to. The only reason redstone repeater is there is to stop this line of redstone receiving the power from that redstone torch below. You'll then have 2 blocks going out. Again, it doesn't really matter what type of blocks these are. I could just use the terracotta again. 2 bits of redstone on the top there like that, and then your redstone torch underneath. Above this, you'll then have your top row. I'm just going to place a block against that, like so. And then your button. So this is your call button, this is your select floor button, and this is your confirm floor button, and then this is your analog lever for selecting the floor. You then can place a Nixie tube above this as a permanent floor indicator, or permanent target floor indicator, I should say. So if I set this to 3, it resembles 3. If I set it back to 1, it resembles 1. I should just point out here, there is no floor 0 due to the way that this works. If you set it to 0, even if it indicates 0 here, there is no corresponding floor, nothing will happen. It will just assume that you've said floor 1, or whatever your previous floor was. Yes, so that is that. The next circuit is going to be our floor detection circuit, and I'll also use this time to finish off the door circuit. So first of all, for our floor detection circuit, you're going to want to build or place 2 blocks like so. You'll have a comparator running off one of them. Yet again, in subtract mode, there'll be a repeater running into it like so, and then on the back of this, you're going to want another redstone link. So another redstone link here like that. This redstone link is going to be our floor detector. I'm just going to grab a regular torch here. Again, it doesn't matter what you use as long as it's consistent. And yeah, that's that part so far. Now, to power this, we need to build off the back of our green circuit down here. So I'm just going to switch back to this yellow terracotta. Again, doesn't matter what colours you use, what blocks you use, as long as they're redstone capable. I will place a block up like that, and then another one here. I'm going to run a piece of redstone into the back of this, and then I will place a redstone torch here like that. Now underneath this, I will place, actually I could have just done that earlier, 1 block up, and then our piece of redstone on top running in. So now, as I sort of showed off earlier, if we have a passing elevator, it won't open the doors. If we wait for long enough, or rather stop at this floor, our doors will open, and there'll be a nice little delay before they close too. So that is the sort of, that's all you need for one floor. I will build up a bit and create another floor, and then I'll create the control circuit as well to show you. Okay, that's facing the wrong way. Let's fix it. There we go, like that. You can see that that works, good. And then we'll just build our actual elevator chassis here too. So for the elevator chassis itself, we'll place your other redstone contact against this. You're going to grab whatever blocks you want the elevator to be built out of. I'm going to use dark oak and andesite, so andesite for the floor. Place that like so. You're at this point going to want to grab your glue, super glue, and you're going to want to glue all those blocks together there. You then want to create the back wall here. Again, you'll super glue the section here to this. If you want a ceiling, I had mine set to framed glass trapdoors. You can place them like so, and there's another one there just for that. You'll then glue these to that, and so that's just the elevator blocks here itself, they're glued. And then aside from that, we can actually get started on the control circuit. First part is our pulley, rope pulley that is. We'll place that on this corner block here. You then want a shaft. You only need one of these, and really you could probably get off without it, however it would make the elevator look a bit weird. So I put a shaft there. It then looks a bit nicer with an andesite casing wrapped around it. Nope, not pulley, andesite casing, like so. And that allows you to basically hide the shaft that's running there. Just put some of these here. Then need your gear shift. And the other one is the clutch. Yes. Don't know why I put capsules on. Anyway, gear shift and clutch. So can place these now side by side. The clutch, the first one, goes here like that, and then you can have your gear shift afterwards. You'll then have the two redstone links I brought up earlier. Different from these ones, these are going to be on different channels. These ones will run off of the memory circuit that we'll create in a moment. Let's use these with, actually let's grab the dye that we were using earlier. So we'll create yellow dye for one, and that's another common dye, red dye for the other, let's say. So our clutch we'll use yellow dye for, and our gear shift we'll use red for. Again, use whatever makes sense to you. You'll then need some sort of power source, so you'll run this out to maybe like water wheels or something, or a windmill. Because I'm in creative right now, I'm just going to grab a creative motor, and I'll just slam that on in there like so. You can see that it's already went on its way down. There's currently no logic circuit behind this, so it's just going to keep going when it reaches that bottom floor. Well, you can see that the door's open because it's moving so slowly. So, actually, one thing that's worth noting is the best possible state to run this at is 32. If you run it at 48, the doors will be a bit buggy. And if you run it any slower than 32, the doors will be a bit buggy. So at speed 32, that's optimal. That's pretty much it for the actual core elevator area itself. I realise I've forgotten the controls here. Let's just grab some of those real quick. Okay, doesn't matter if they're linked up, they'll do the job. Although it's easier to visualize with the Nixie tubes, so let's grab those two. Yeah, Nix tubes. There we go. And just double check, that's, yep, that one's set to 2 of 15, that's set to 1 of 15. Okay, good. So this is our floor 1, this is our floor 2. I will now get started on the control circuit. So for the actual management circuit itself, some of it is going to look quite familiar to some of you. Certainly if you're familiar with analog memory latches. So start off with typical redstone comparator latch. You want this one to be in subtract mode, you want redstone dust here, here, and here. The only difference is we're going to place our first redstone link there like so. We also want a second analog latch, and we're going to place it here this time. Just us here, here, and here. So basically a mirror of what we have there, right down to the receiver. And noting that they are receivers, I should place them both in receive mode. So just grab your wrench and right click them to turn them into receive mode. This design isn't accidental, it's actually quite intentional. We're going to place another comparator here like this, and one on this side. And this will give us, one of these memory circuits will be used for the current floor level, the other one will be used for the floor selection. And this will allow us to say, is the current floor greater than the selected floor? Is the selected floor greater than the current floor? If neither of those things are true, is it greater than or equal to? I think it's greater than or equal to the current floor. If both of those things are true, then that can only mean that the current floor is exactly equal to the target floor. So to build that in, it's just a nice, simple AND gate of sorts. We're just going to grab a different color terracotta. Let's grab pink this time. I think green would be a bad mix against all this grass. So the terracotta there, block on top, more blocks out this way, another block here, torch on top, block on top, and then redstone dust right the way along. On this side, you want another redstone link. This one's going to be our transmitter for up here. And then the other one, we want a slightly different circuit. So on this side, anyway, so place a torch there like so, and we'll run this one into a block, and this is going to be another comparator. So signal redstone dust there, redstone comparator here, and then finally last link there like that. Now, this side here is going to be our clutch control. Let's pop our yellow dye in there like so. We said that the gear shift was red, so pop a red in there like that. The floor selection should be this one, which is our redstone torches, and floor detection is this one with our regular torches. To start off with, given that this is actually our floor detection one, we can leave this at 0. We could set the target floor quite high to start with, and that should move it up. We can see that moving up, which is great. When it reaches up the top here, we can reset this, and it will also reset our current floor to value. So this should now be, so that's set to 2, which is our current floor. Target floor is still set to 15. Good. If I set the target floor to 1, these doors should close and we should head on down. Or if I missed something. Got our dust here. That's right. So you need a torch there like that, and there we go. That's that. And do the same for floor 2. It should send us back up on our way. Floor 2. There we go, and let's go back to floor 1. Down we go. A little bit of a springboard effect there, but we did stop at the right floor, which is good. And yeah, I think that's it. So, yep, just make sure that you remember that torch that I forgot there, and you should be all good. Thank you for tuning in to this video. I hope you enjoyed it, and I hope this design is of use to you. It's certainly what I'm going to be building in my survival world, which is a clone of the world that I'm currently in, actually. Stick around, because I'll likely be putting out lots of similar videos, although hopefully no more on elevators. There's been a good few hours put into this behind the scenes, getting this working. So yeah, thank you for watching, and I'll hope to see you again next time.